Welcome dear viewers, Shoaib is here with an interesting lecture of the induced EMF and also the types of the induced EMF. In this today's lecture we will discuss. Before discussing the types of the induced EMF, just we have to little bit discuss the concept regarding the induced EMF. In the previous lectures we have discussed the Faraday's law of electromagnetic induction, the electromagnetic induction process. Okay. Now, induced EMF means the EMF which is induced in the conductors or in the coil, that is called as the induced EMF. As you can see from the board, when magnetic flux is linking with the coil or the conductor is changes and EMF is induced in the coil. So this is the main explanation of the Faraday's law of the electromagnetic induction. Okay. So here we are taking the two cases for the production of the induced EMF. In the first case, the magnetic field is stationary, the field is stationary and conductor is in the revolving condition. And in the second condition, the conductor is in a stationary form and field is in the revolving condition. So let us discuss the conductor is revolving and field is stationary. Take the example of any kind of the AC or the DC generator. If we are taking the DC generator, then a DC generator comprises of the two windings, the field winding and the armature winding. The field winding is a stationary winding which is excited from the DC supply to produce the magnetism in the field winding. And also your armature winding is the rotating winding, because in the generator action we need the prime mover to convert the mechanical energy into the electrical energy. So this is the property of any generator, either it is DC or the AC one. So your armature terminals or the armature winding is to be rotated with the help of external prime mover. The prime mover may be your steam turbine, gas turbine or any kind of the engine to rotate the shaft of the generator. So that what happened, the armature winding, which is the rotating winding, is going to be rotated in the direction of the magnetic field, and already the field winding is excited from the DC source. So here the lines of the cuts of the conductors is to be takes place according to the Faraday's law of electromagnetic induction. Whenever a flux is linking with the coil is changes and EMF is induced in the coil, that is the generated EMF or the induced EMF within the armature conductors, within the rotating conductors. So that is called as the generated EMF. And this type of the EMF, when your conductor is in the revolving condition, in the motion, and your field is stationary, this type of the induced EMF is called as the dynamically induced EMF. So as you can see the description from the board, the conductor is moved in a stationary magnetic field in such a way that magnetic flux linking it changes the magnitude, and the EMF is induced in such a way that is called as the dynamically induced EMF, that I have explained through the generator action. Okay, so it is called as the EMF which is induced in the conductor is due to the motion form. Okay, number second case is the very interesting one. Here the EMF is also being induced, but that induced EMF is called as a stationary induced EMF, because here the magnetic field is in the revolving condition, revolving or in the motion, and your conductor is in the stationary form. As you can see the transformer action, the transformer comprises of the two windings, the primary winding and the secondary winding, and transformer both winding has no any kind of the moving part and the rotating part. So what happened, your AC supply is you are given to that primary winding, and your secondary winding means EMF is induced in the secondary winding. It is due to the because of the movement of the magnetic field, revolving of the magnetic field from one winding to another winding through the magnetic linkage. So in this type of your production of the EMF which is produced in the static machines, so that will be called as a stationary induced EMF, and this type of the stationary induced EMF is totally produced in our like in the case of your transformer, because transformer is an electrical piece of the equipment which is used to raise or lower the amount of the voltage at the constant power and the constant frequency. So this was the little bit idea regarding the induced EMF. Okay, now we are going to describe the self induction like in your mutual induced EMFs. Okay, now what is the self induced EMF? As you can see from this diagram, this is the coil which has the n number of the turns. Okay, and you are energizing this coil from the any kind of the source. Okay, and variable resistor is to increase or decrease the amount of the supply current from that, and you can easily increase or decrease or change the magnetism effect in your coil. And here if the magnetism effect of the coil is to be increased or decreased, so EMF which is produced in the conductors or in the number of the turns of the wire will be increased or decreased as changing in the supply voltage. Okay, so EMF induced in the coil, as you can see from the board, the definition is that as the EMF induced in the coil due to the change of its own magnetic flux linking with it, that is called as self-induced EMF. Means the property of the coil changes its own your magnetic flux through itself, that is called as a self-induced EMF. Okay, now consider this coil. A magnetic field is established through the coil. If you are apply the voltage towards this coil, then what happen? Your currents are being induced in our windings of the number of the turns of the wire within the coil, and if the current is to be varying with respect to the variable resistor, then EMF will be greater or lower as increase or decrease in the EMF which is induced in, which is to be supplied from that source side. Okay, so if you are increasing the amount of the supply voltage from here, obviously the currents or the EMF which is induced in the coil will be the greater one, and if you are decreasing the amount of the supply voltage from that your supply side, obviously the EMF which is induced in the conductor side in your coil will be decreased. So this type of the induced EMF is called as a self-induced EMF, in which the property of that coil to changes its magnetic flux on its own or means which is linked with that own, so that will be called as your self-induced EMF. So there is another type of the induced EMF which is called the mutually induced EMF. Okay, in the mutually induced EMF we have required the two coils, the coil A and the coil B. So this is the type of the induction or your mutually induced EMF application is totally applied in the case of the working of the transformer. The coil transformer has the primary winding and the secondary winding. The primary winding is energized from the AC supply, and induced EMF is to be produced in the secondary side, and between these two windings there is no any kind of the electrical connection, but they have the magnetically coupled to each other. Okay, so let's discuss the description of that your mutually induced EMF. EMF is induced in a coil due to changing current in the neighboring coil, that is called the mutually induced EMF. For example, here are the two coils A and the B. A coil is connected with the supply side, so your voltage source is to be connected with the A coil, and if you are increasing or decreasing the voltage in your A coil, obviously the current will be or EMF which is induced in that B coil will be increased or decreased as changing in that the value or the magnitude of that coil A. So that magnetically coupling between the two coils is called as the mutually induced EMF. Okay, so consider the two coils and the B. Okay, a part of the magnetic flux produced by the coil A passes through, and that will be the links with the B. This magnetic flux is common to the both your coils, A coil and the B coil, because as you can see from the diagram, there is no any kind of the electrical connection between the two coils. Okay, the both coils are magnetically coupled to each other. Okay, if current in a coil A is varied, if you are supplying, because in this diagram we are given the supply to that your A coil. Okay, and if the current in a coil A is varied, then EMF is induced in the both coil. In this A coil, if the current is to be varied, so the EMF which is induced in the coil A is called self-induced EMF, and because of the variation in the current within the coil A, the EMF which is induced on the secondary side, which is the EMF which is induced on the B coil side, so that will be called as a mutually induced EMF. Okay, so EMF induced in the coil A is called as a self-induced EMF, because if you are changing, increasing or decreasing the amount of the magnetic flux within the coil A, so that will be called as the self-induced EMF. And if you are with the magnetic coupling between the two coils, if you are increasing or decreasing the amount of the current within the coil A, because both coils are magnetically coupled to each other, so there will be the changing in the magnitude of the current in the coil B, so that will be called as the mutually induced EMF which is produced in the coil B. Okay, the magnitude of the mutually induced EMF is given with the help of the Faraday's law of electromagnetic induction. E is equal to n d phi over dt. Okay, and if you are taking the here example of the coil B, number of the turns of the B side, and flux on the which is coupling as a which is used as a coupling source medium between the two coils. Okay, connecting the two coils as a coupling source, coupling medium, which is a magnetic flux. So with respect to the time, it varies, its magnitude is to be varies, so EMF is induced in the coil B. Okay, so the direction of the mutually induced EMF is again to be described by the Lenz's scientist, so as to oppose the cause which is given to riser. So for example, if the currents which are induced in the coil B which are produced in the coil B opposes the cause which is given to produce it, which are generated or which are produced due to the coil A. So induced EMF, types of the induced EMF, self-induced and the mutually induced EMF, we have discussed in our today's lecture. And just in the mutually induced EMF, the two laws are being verified, the Faraday's law and also the Lenz's law. The Faraday's law means the EMF which is produced in the conductor because of that your change in the magnetic field, where that will be linked with that conductor. And in the coil B, the EMF which is induced due to the the EMF which is induced in the coil B is because of the currents which are to be supplied to the A coil. So the currents which are produced in the coil B are opposite to that A coil current. So this is according to the Lenz's law. The direction of the induced EMF is opposes that cause which is given to rise it or produce it. So this was the whole lecture regarding the induction, regarding your self-induced EMF and the mutually induced EMF, and I hope that you have understood today's lecture. And at the last, please don't forget to subscribe my YouTube channel Shoaib Dayo for more informative videos related to the electrical engineering area. Thank you very much, viewers.